Okay guys, so for the first lesson of this week, I'm actually still following a book. So when you see numbers like this, 1.1, that's more for me, I guess, because it correlates to where I am in the book. It really doesn't matter to you because you don't have a textbook. Everything you're doing here obviously is online. So you'll see this over and over, don't worry about it. The topic is evaluating expressions. This is a review topic. It's not really Algebra 2. It's kind of one of those things that you kind of just take for granted everyone knows it. But after a long summer, you kind of dust off the cobwebs in the brain and kind of get back on track with some math. So it's not unusual to see a couple review topics. So what we're going to be looking at is order of operations and mathematical substitution. And under substitution, you'll see I have a note here that negatives can be an issue. So we're going to talk about that. But first, order of operations. So you might be familiar with what I'm highlighting here, PEMDAS, or please excuse my dear Aunt Sally, whatever. This is the order. Oh, and I just realized I spelled parentheses wrong, so I got to fix that. This is an agreement, sort of universally, which order to do math when it's written down. Historically, there was a time where there was no order, so if there was a math problem like 5 plus 2 times 3, a mathematician in one university might do 5 plus 2 is 7, and 7 times 3 is 21, and another mathematician somewhere else would say, oh, this is 5 plus 6. You do the 2 times 3 first, and 5 plus 6 is 11. And in math, we don't get along real well if the same problem gives two different answers. We like to have one exact, concise answer as much as possible. So it was agreed that grouping symbols, and there's a number of them, parentheses, brackets, absolute value bars, even a fraction bar can be a grouping symbol, that those would always be looked at first and anything inside there worked out. E stands for exponents, could also include roots. Excuse me. Then you multiply or divide in a problem from left to right. Sorry. If this problem has multiple steps of multiply and divide, you don't do the multiply first because m comes first in the little saying. It doesn't work that way. You always multiply or divide left to right. Similarly, add or subtract, which is the last step. If you have adding and subtracting in the same problem, you just read left to right. As far as substitution goes, oh, and I'll do examples, obviously. Substitution is when you plug in a number for a variable. The only issue is exponents. So exponents can mess things up. So if I were to say, hey, x equals -3, what is x squared? Well, unfortunately, there's two ways to interpret this, and one way is correct. One way to interpret it is like this, and one way to interpret it is like that. And so which one is correct? Well, I'm going to erase these and talk about it a little. X squared, the concept of x squared means x multiplied by itself, x times another x. If both of those x's is a -3, that means we want to do -3 times another -3. Therefore, the answer is +9. So the answer we know is going to be +9. I need to move this down and give myself a little more room. So is that equivalent to -3 squared like this, or -3 squared like that? Well, when the notation for exponents was created, it was kind of written or assumed, maybe not written, but assumed that everyone knows that whatever the power is written next to is what it applies to. So in this scenario here, -3x squared, the squared only applies to the 3. So this literally means there's a negative sign followed by 2 3's. And this one works out to be -9, which of course is the wrong answer. We want +9. In the second notation here, again, the power applies to whatever it's written next to. Well, this is written next to a parenthesis, and since parentheses come in pairs, that power applies to the pair of parentheses. So, hold on. So, -3 in parentheses squared means there's a -3 times another -3, and the answer is +9. So it turns out that when you plug a negative number in for a variable and there's an exponent on it, you're supposed to use parentheses in order to get the right answer. The reason this is confusing is if we look at x cubed, if you do negative 3 cubed this way, which is technically wrong, or negative 3 this way, which is correct, it turns out that you get the same answer, which, you know, like I said, adds to confusion. This first one is negative 3 times 3 times 3, which is negative 27. This other one is negative 3 times another negative 3 times another negative 3. Well, 3 negatives, when you multiply them together, equal a negative, and 3 times 3 times 3 is also 27, so you get the same answer. So like with x squared, you get two different answers. With x cubed, you get the same answer. And then you look at x to the fourth to beat a dead horse. Negative 3 to the fourth versus parentheses negative 3 to the fourth. This one is negative 3 times 3 times 3 times 3. There are 4 3's, one negative sign. This works out to be negative 81. The other one is negative 3, so there's going to be 4 negatives and 4 3's. Remember, every time you multiply two negatives together, it makes a positive. So these two will cancel out, make a positive. Those two will cancel out, make a positive. You get positive 81, which is the right answer. So as it turns out, when your power is an even number, plugging it in parentheses makes a big deal. It's the difference between right and wrong. When the power is an odd number, technically you're supposed to use parentheses, but if you don't get the wrong answer. So it's like, who cares? This also comes up with calculators. So I'm going to split my screen for a second and just kind of show you. If you were to do negative 3 squared like this, you get negative 9. You do parentheses negative 3 parentheses squared, you get positive 9. So the calculator knows the difference as well. So when you're plugging numbers in, parentheses can make a big difference. If there's ever any doubt, if you always use parentheses, you'll get the right answer. You'll end up writing more on your paper, which might be a pain, having to write all these little parentheses symbols everywhere, but you're guaranteed the right answer. It just so happens that there's times where you don't need parentheses. Okay, let's look at some examples. We're going to start with some regular order of operations, and then we'll get into, well, the instructions say evaluate, which is where you plug in a number or substitute. So here, again, I'll do evens. Some of you are looking at this and like, oh, I hate this, and so it's probably worth a review. Others of you are like, oh, I had this, 3 years ago in math. Why are we doing it? Just stick it out, do your best. We'll get into harder stuff later if that's what you're craving. All right, so parentheses, exponents, multiply, divide. So there's parentheses here and here. So parentheses is the first step. That means you can do these simultaneously. 4 plus 4 is 8, and 5 minus 2 is 3. Now we have 8 sitting next to 3. That means the same thing as 8 times 3. We just don't like to use the x for times in algebra because, variables. So 8 times 3, 24, that is the answer. You can do mental math if you need to use a calculator. Hopefully you don't need a calculator for 4 plus 4 or 5 minus 2. But if you get into some bigger numbers or you just want to be extra sure, feel free to use a calculator. We'll see the answers right there. Next one. Okay, so this is an example, when I said before, where a fraction bar can act like grouping symbols. This creates a group down here that you need to work out first, just like as if there were parentheses. So 1 plus 1 is 2, that's 12 over 2. Now I said we don't use an x anymore, and here's an x. Yeah, that's my fault. I can sort of tweak the software that I use to use a dot instead of an x, and I forgot, apparently. So anyway, now here we have multiply and divide. We need to go left to right. So, plus the fact that this is fraction bar is sort of a grouping symbol would be just like this. You got to do that first. So 12 over 2 is 6. 6 times 3 is 18. And if you find these tedious and you don't really want to do them, I guess the upshot is it's one day and there's not a ton of problems and they should go fairly easy for you. Number 6, again, more parentheses, so we can do them simultaneously. The first one, 4 minus 2 is 2. Now the second set of parentheses has multiple steps. We are going to divide before we add. 18 divided by 6 is 3. And then we continue to finish what's in these parentheses. 3 plus 6 is 9. And 2 times 9 is 18. Now there are always shortcuts that you can find for order of operations, and you're certainly welcome to do that as long as you get the right answer. I'd like you to avoid just doing everything on the calculator. Try to engage the brain a little bit here. So yeah. All right, let's do number 8. So again, these fraction bars are as though there would be parentheses there. So 14 minus 2 is 12. So I'm working down this way, and 12 over 4, 12 fourths is 3. And times, I'm going to go ahead and change that x to a dot. 12 fourths, 12 divided by 4 is 3. 3 plus 3 is, I'm sorry, not plus, that's times, clearly. 3 times 3 is 9. 9 plus 4 is 13. And when it comes to showing your work, I mean, come on, you've been doing problems like this for a few years. I'm going to be fairly understanding if you don't have all this junk written out. It's totally okay. Again, just try not to, well, obviously don't just copy all the answers from down below, and don't do the whole thing on the calculator. Do some of the steps on paper so I can see you're working. All right, so there, again, for the odds, you'll be doing 1 through 7, the odds, very similar to the ones that I did. Now we're getting to evaluate. So plug in numbers for variables and work it out. Now, what I said before, when you do a substitution, technically, you can use parentheses everywhere you do a substitution, and you will get the right answer. So xz means x times z. In the where the x is, I put parentheses there. I'm going to put a 3. Where the z is, in those parentheses, I'm going to put a 2. So now it looks like 3 times 2 times 4 plus 4. Once you do the substitution, plug this in here, just like I did, what you now have is one of these problems. So assuming you can plug the numbers in right, it's the same math as up above. Now I said if you use parentheses every time, you'll get the right answer. This will give us the right answer, but let's face it, if I didn't have those parentheses there, you don't want 32. You still need to put something for times 3 times 2 times 4 plus 4. This is a case where the parentheses are really irrelevant. This will still give you the right answer. All right, so 3 times 2 times 8, right, parentheses first. Multiply left to right. 3 times 2 is 6, and 6 times 8 is 48. And there's the answer. So whether you use the parentheses or not on number 10 shouldn't matter, as long as the answer is 48. Where am I? There it is. Let's look at, number 12. Okay, so now we do have powers. Powers are the ones you need to look out for, and plugging in a negative number can be the tricky one. So what I'm going to do first would be incorrect. If you write -1 squared minus 4 times 2 cubed, that is wrong. That'll give you the wrong answer. When you plug a negative number in and there's a power, you should put it in parentheses. Now this will give us the right answer. So parentheses first. Okay, these are parentheses. You can't do anything in them. They're just holding the -1. So after parentheses is exponents, we need to do exponents. We need to square. What is -1 squared? That's -1 times another -1. That's +1. And then we have another power over here. Now let me ask you, does this 3 apply to the 2 only, or the 2 and the 4? Think about that for a second. Okay, what I said before, the notation for exponents is they apply to whatever they're written next to. This 3 is written next to the 2, so it only applies to the 2, not the 4. What is 2 to the 3rd power? 2 times 2 times 2, 2, 4, 8. So we've done, there were no parentheses to do anything with. We did the exponents. Now multiply. Next step is multiply. Multiply, divide. There's no divide, but there is multiply. 4 times 8 is 32. And then add or subtract 1, take away 32 is -31. So the answer to number 12 should be, where is it? Oh, good grief. I'm smart. -31. All right, last one. Last one, our answer should be -22. Let's do this. Oh, that's just written to look like a nightmare, isn't it? So everywhere there's a J, I'm going to put in a 4. And everywhere there's a K, I'm going to put in a 2. So what did I do with all those parentheses? It's just a way to process it. You don't need to do that. But basically, I wrote my work directly underneath the problem, well, as directly as I could. And so obviously where there's a -2 here, I wrote a -2 below it. Everywhere there's a variable, I just put a set of parentheses, and that kind of gives me a framework, tells me where to plug things in. So wherever there's a J, I'm sticking a 4, that's right there. Wherever there's a K, I am sticking a 2. Now, did I really need the parentheses? Not in this problem. I did not plug a negative number in where there's an exponent, so I could have very easily just done this, and it will give me the same correct result. I don't want to waste your time, but if you were to type this into a calculator with the parentheses and all, and you type that into a calculator, you'll get the exact same answer. Speaking of answer, let's do this. So parentheses first. We have parentheses right here. -2 minus 2 is -4. After parentheses is exponents, we have an exponent right there. 2 squared is 4. 4 times -4 minus 2 minus 4. After parentheses is multiply or divide. We have multiply right here. 4 times -4 is -16 minus 2 minus 4. Add or subtract from left to right. So I'm going to go left to right here. -16 minus 2 is -18. -18 minus 4 is -22. And I think that's what we said the answer should be. Right there. Okay, so let's wrap this up. Your assignment is obviously the odds. Check your work before you submit it. Show work as much as possible. I showed as many steps as I could. You're going to do some things in your head, and that's fine. I understand if your work doesn't look exactly like mine. I just should not see answer, answer, answer all the way down the page. I need to see a little more than that. If you have any questions, drop a comment in the Google Classroom, not on YouTube. Don't put comments there. Or email me, and I'll get back to you as soon as possible.